To solve this next log equation, what we need to do is first we want to cancel out the logs, but I can't just do that when there's multiple logs. So the first step we have to do is actually condense this into a single log on one side. So remember, addition condenses to multiplication. So what I'm going to do is going to condense, so that means I write the word log only once, and then we have z times z minus 3. And this is still equal to 2. So now that it's condensed to a single log, now we can work on canceling that out. And remember, to cancel out a logarithm, we use an exponential with a base of 2. So we're going to exponentiate or turn it into an exponent with a base 2. And again, the way we do that to exponentiate is we use a big 2. And so now this reads 2 raised to the log base 2 of z times z minus 3 power. And what we do to one side, we have to do the other. So now we have 2 raised to the second power. And the reason why I do this is because now an exponential base 2 and a log base 2, those cancel out. And what are we left with? Well, here I have z times z minus 3 is equal to 2 squared, which is 4. And if I distribute that z, I get z squared minus 3z equals 4. And now we see, okay, it's quadratic. Looks like we have to solve this, and factoring is almost always the way we're going to go when it's nice, simple numbers. So z squared minus 3z, and if I subtract the 4, I get minus 4 is equal to 0. And now we can solve by factoring. And let's see, I know z times z is equal to z squared. To get negative 4, I'm going to try 4 and 1, maybe 2 and 2, but let's try 4 and 1 first, with a minus 4 and a plus 1. And I do the inside outside, so inside I see I get minus 4z, so I'll just write it to the side. And outside I have z times 1 is 1z, which adds up to minus 3z. So good, that's what we wanted in the middle, is minus 3z. So then we just solve each one using the zero product property. So splitting this up, get z minus 4 equals 0 and z plus 1 equals 0. And so my solutions are z equals 4 and z equals negative 1. However, it does remind you to make sure you check for extraneous solutions. So remember, what that means is make sure that these are actually solutions and they're not just ones that look like solutions but from when we solved it, but we're not really. So the way we do that is we just plug it in on our head. So let's start with 4. Just make sure that we don't take the log of a negative. So if I plug in a 4 here, we take log base 2 of 4, that's possible. And also 4 minus 3 is positive 1, so we're taking the log of a positive in both cases. So this one's a solution. However, when I try doing z equals negative 1, I can see right away that when I plug it into here, I have to take a log of negative 1. And since we can't take the log of a negative, we just cancel that one out. That one's not a solution, it's an extraneous one. So our only solution is z equals 4, which is B.